Good morning or afternoon, depending on where you are. Welcome to the NWS webinar series. Our October episode is going to be talking about heat. And since we just got finished with our summer, I'd be really interested to hear about this too. I'm at the WFO in Las Vegas, and one of my colleagues, Chelsea, is actually going to be presenting. So I'm particularly interested to hear what we're talking about today. And I'm initially joined here by Danielle Nagele, the Public Weather Service Program Manager that is at the National Weather Service headquarters. And we actually went to the same college. We are both Texas Tech alumni. So it's really cool to actually be able to be on the webinar here with you today and learn a little bit more about what you guys are working on up there at headquarters. So without further ado, I'm going to hand it over to you, Danielle, to host us for the rest of this hour. So good luck.
Awesome. Thank you, Trevor. Yeah, so as Trevor mentioned, Danielle Nagele, I'm with the public program, and I am currently, oops, sorry, didn't mean to switch slides. Oh, sorry, there we go. Got everything together now. So I'm currently the acting public program manager. My normal role is the public program coordinator. And now I think I can go on. All right, so keep hearing public program. First, I want to start with just a quick overview of what the public program is if you're not super familiar. Going even further than that, if you go over to the right-hand side, you see two maps here. At the top, you see our National Weather Service regions. If you're not familiar with those, we have 6 of them, and you'll see Alaska and Pacific there as well. And then below that, we have all of our 122 CWAs, or county warning areas. And so these are under the purview of our weather forecast offices, or WFOs. And those are all color-coded and listed out there on that second map. And then for the public program specifically, we have quite a few things under our purview beyond just heat. So they're listed here. We have extreme temperatures, of course, so yes, cold, heat, as well as frost and freeze. We have non-convective wind, dense fog, freezing fog, dense smoke. We have dust, so blowing dust and dust storm, ashfall, air quality, and also health considerations. So quite a few things under the public program, but today we're going to focus on heat. So to start out, I'm going to first start to talk about heat index, which is really our traditional measurement of heat stress, and it's what's used to inform our watch, warning, and advisory products. So it was developed in the 1970s by Stedman, and it actually does incorporate several different parameters and assumptions into it. We've listed a few out here on the slide. It's not actually just temperature and humidity. It also incorporates assumptions around body mass and height, clothing, physical activity, heat tolerance, sunlight, wind speed, and more. So you'll see an example here of a 5'7" adult, 147 pounds, walking at about 3 miles per hour. So these are the assumptions that go into that heat index equation. But there's much more in the way of heat tools than just heat index. And we're going to cover some of those in just a moment here. So that begs the question, how do we really message and manage multiple different heat tools in our toolbox? So I'm labeling this as a challenge and an opportunity. And I'll use this moment to point out that the Weather Service is working toward a unified heat strategy that, one of the things we want to look at in that strategy is exactly that. How do you message and manage these multiple tools? So that's just one facet of advancing our heat services and Weather Service. Our strategy will also focus on things like advancing these tools effectively and providing consistent service, also developing new partnerships and enhancing our current ones, as well as really strengthening and involving our heat messaging and outreach components. There you go. So before we go any further, I want to make sure we're on the same playing field here when it comes to our watch, warning, and advisory criteria and thresholds. So excessive heat watch are when conditions are favorable for an excessive heat event to meet or exceed local heat warning criteria. So you'll hear that phrase a lot, meet or exceed local heat warning criteria. The point being here that while we have national guidance that I'm showing here around issuance of these products, we always encourage our local WFOs to work closely with their partners to come up with more localized and targeted thresholds that better meet the needs of their CWA. So for heat advisory, this is when heat index values are forecast to meet those local criteria, but we do offer some national guidance here. So for northern states, the heat index will be greater than 100 degrees Fahrenheit. And in the southern states, heat index would be greater than 105. There's also a minimum nighttime low component here of greater than or equal to 75 degrees. Excessive heat warning, same thing here. We, of course, say that we want the forecast to meet or exceed locally defined warning criteria, but for the northern states, we give the guidance of heat index greater than 105 degrees and southern states greater than 110, again with the minimum nighttime lows of greater than or equal to 75. Okay, so I mentioned earlier about some of our future heat tools within Weather Service. So I'm going to describe them now. Wet bulb globe temperature being the first one, WBGT, it is currently experimental. So you can actually find this on our NDFD page or National Digital Forecast Database. And you'll see that as a grid within that. So what wet bulb globe temperature does is estimate the effect of temperature, humidity, wind, and solar radiation on the human body. So what we always like to say with wet bulb globe is that it's an effective indicator for heat stress for active populations. So it's very good for people that are outside active in the sun doing work or recreating outside during hot situations. So that's really where its use comes into play. It can be a little confusing because it tends to be less than the heat index. So it may make you feel more comfortable because it's a lower temperature. But if you look over at the scale to the right here, this is actually within our definitions page on our NDFD page. And it lays out the color-coded threat levels for wet bulb globe temperature. So you see here, you don't have to get that high to get to an extreme threat. If you're in that region 1, and it's greater than 84 degrees, you're in an extreme threat. So definitely different than what you would see with the heat index. And just to describe the regions real quick, these are climatological regions that were developed as part of an analysis by Grunstein et al. It's actually in there, it's just very small, just above the regions map. And so you have 3 regions. Obviously, you have the region 1 is more of the northern climate. Then you have this mid-level region 2, and then the southern states in region 3. So you'll see 3 different values for wet bulb globe temperature laid out there, and then labeled from low to extreme threat. Another thing I'll point out is that we, as the National Weather Service, we really can't make exact recommendations for actions to take at each of these threat levels for a couple reasons. There's a lot of variation when it comes to how heat interacts with the human body. There's just too many variables that go into that. And also it just depends highly on the situation and the location. Beyond that, there's also quite a few different applications and standards around wet bulb globe temperature that are already developed out there, such as the US Soccer Team, American College of Sports Medicine, and Corey Stringer Institute, just to name a few. Moving on to heat risk. So heat risk is a prototype that was developed by our Weather Service Western region, and it includes climatology, duration of heat, overnight temps, and the difference between highs and lows. Another thing it takes into account that's unique about it is CDC mortality and health information. So all of this pulled together is developed into an index, and you'll see an example there of the scale, and it's color-coded as well as numbers, and it gives a meaning of what the risk level is for each of those. And in this case, heat risk is really meant for providing additional information ahead of a watch warning or advisory being issued. So it's great for those that might need to take action before we issue that warning. And just to give a little more information for those particularly vulnerable to heat. And finally, I just wanted to share some of our outreach and education materials that we have available around heat. First off, our seasonal safety campaign. Heat is involved in both our spring and summer campaigns. So you'll see that come out for both of those seasons. And we've just integrated in quite a bit of information on vulnerable populations. We've also added that to our heat safety website. You'll see an example here at the bottom. We label 5 main categories of vulnerable populations: pregnant, women, newborns, children, elderly, and also those with chronic illnesses. So that information has been added fairly recently. Additionally, we do try and develop out our federal agency collaborations. One example of this is with OSHA. We have agreed on particular language within our Weather Service watch warning advisory products. And so you'll see an example of that here. This language will be seen in all of our call to action statements within our products. Beyond that, we of course have a cadre of various graphics available, as well as social media posts that come out from the national level, as well as from our local offices. And now it's my pleasure to flip it over to Greg Carbon, who's joining us from the Weather Prediction Center, or WPC, and he's our Forecast Operations Branch Chief. So Greg, I will pass it over to you.
Hopefully, maybe I should put it back. Let's see. I'm going to look down here. How's that? Good afternoon or good day, everyone. Greg Carbon here. Going to talk a little bit about the summer season, focused primarily on June, July, and August with respect to the national picture over the contiguous United States, and do a review here. I'll take a look at the CPC seasonal temperature outlook along with visual verification. The summer temperature review includes the climate extremes index. We'll take a look at that, the highest summer climate extremes index on record this past summer. Year-to-date totals for max temp days greater than or equal to 90 and minimum temperature days greater than or equal to 70. New all-time high max and high min records are occurring June, July, and August of the past summer. And then some heat wave visualization, messaging, some talking points out of the WPC, and a look at some resources available to meteorologists both within the National Weather Service and outside the Weather Service as far as heat, messaging, and context and understanding. And then I did do a review of NWS heat product summary maps using the excellent interface of the Iowa Mesonet site. Normally I'll do some of those maps on my own, but I just didn't get to that this year. But Daryl Hertzman's site is just fine for that. So let's get underway. Next slide, please. So here's a look at the CPC temperature outlook that was issued for the 3-month period, June, July, and August. This was the last outlook issued before the beginning of June. So I think the issue date on there is May 20th, showing the high chances of well above normal summertime temperatures across the Southwest. Not much of a signal high or low across the Midwest, Western Great Lakes region, and then another signal for above normal temperatures along the entire eastern seaboard from Florida to Maine. Well, how did that outlook work out? On the right, you see the mean temperature percentile ranks for June through August from NCEI, showing that not a bad forecast across much of the West and even parts of the northern high plains from Montana east across the Dakotas. Perhaps a little underdone or not much of a forecast signal there for northeast Minnesota. Perhaps a big surprise of the summer was well below, not well below, but below normal temperatures summer-wise for parts of the southern plains. I know when I lived in Oklahoma, a summer like that was definitely one that I would desire. A lot of the below normal temperatures there were due in part to above normal precipitation across much of that area. So a lot of clouds and precipitation tempering temperatures through the summer months. And then above normal in the observations across much of the Northeast, essentially from the Virginia, Mid-Atlantic region up across northern New England. Perhaps the most extreme, and if you lived in there, you know it, lived out there in the Southwest and also the Northwest United States, had their all-time hottest summer on record. And then we'll talk a little bit about why the year as a whole, why the summer as a whole was so much above normal. It wasn't just the Western U.S. that contributed to the well above normal temperatures. So if you go to the next slide, you'll see here that much of the United States had its all-time, if you take all of the states and combine them together, it was the most extreme summer on record going back to 1895. Essentially a tie with 1936, which up until 2021 had been the hottest summer on record. California, Idaho, Oregon, Utah, and Nevada had all-time hottest summers on record. The average max temperature over the contiguous United States was 86.5 degrees. That's over 2 degrees above the long-term average. The average min was even more above normal, about 3 degrees above the long-term average minimum temperature, and that's a new record for the summer months. When you look at this with respect to a 112-year period of record that NCEI keeps track of for the Summertime Climate Extremes Index, 2021 set a new all-time high on that extreme, primarily due to the elevated warm temperatures, but also very dry conditions in the Palmer Drought Severity Index. Those are indices that go into the calculation of the extreme. And so both the Northeast and Southwest experienced record levels of extreme warm minimum temperatures. And I think it was the Northeast warm minimums that also pushed the summer months into new record territory. Next slide, please. A little hard to read the numbers here, but basically just looking at a summary of this is year-to-date rankings. I think I did these charts at the end of September, but the year-to-date number of days with the max temperature of greater than or equal to 90 degrees Fahrenheit, and then the rankings on the right, and essentially see the color bar there. Of course, you're going to see fewer days as you go from south to north. However, look across the Northern Rockies, where 45 to 50 days this past year, essentially breaking the 90-degree mark in that area of the country. And if you look at that with respect to the ranking, that's right up there, all-time record number of days breaking 90 degrees. And then it's very interesting in the South, we saw in the analysis as well, much of the Deep South slightly below normal. And in fact, some places in their lowest couple of rankings there, lowest years of cooler summers than normal across that area, again, primarily due to widespread precipitation. The next slide looks at the minimum temperatures greater than or equal to 70. And this also has some interesting aspects to it. If you move to the next slide, please. Nope, back one, I'm sorry. There we go. The minimum temperatures of greater than or equal to 70 in their rankings. Number of days, again, on the left and the rankings on the right. You can see here where the minimum, the high minimums in the Northeast obviously contributed to the warmer than normal summer across that region. Many of those stations from the Eastern Great Lakes across parts of New England were ranked the largest number of days with minimum temperatures of 70 degrees or higher. And this is a trend that we've been seeing now for quite some time during the summer months, is we're just not reaching minimum temperatures that cool off all that much during the nighttime or early morning hours. And this certainly contributes to the risk of heat-related impacts when you don't cool off as much at night as perhaps we used to, probably a factor in terms of urbanization, but also climate change. And now the next slide, please. I wanted to get these maps just to show June and July were really the killer months across parts of the Western United States. Of course, we saw just an unprecedented heat wave occur in June across the Pacific Northwest. The new all-time high maximum temperatures for June, July, and August on the top of this slide, and then the all-time high minimum temperatures for those 3 months on the bottom of this slide. And you can really see it was the Pacific Northwest in June, that heat, all-time heat settling into parts of the Great Basin, Intermountain West, and parts of the Southwest for July, and then back up into the Northern Rockies for high minimums in August, not quite that many all-time high maximums. What really struck me looking at the records here for all-time high maximum temperatures in the June event in the Pacific Northwest, what was really remarkable is how you broke all-time high maximum temperatures on consecutive days. So I haven't really gone into depth on this, but looking at the data, you do not often see an all-time temperature broken on consecutive days. You may have it once during a particularly anomalous event, and then that's it. You've established a new all-time high. What happened in the Northwest in June, again, I can't think of any other word other than unprecedented, seeing some of those all-time maxes broken on consecutive days by several degrees in some cases. So really quite remarkable, and it's still, I think, difficult, and we can converse about this a little bit with respect to messaging, because how do you message or translate an event that no one has experienced before? Next slide, please. So this is just a review. There's some work I did on the side during the heat wave in June, taking a look at the RTMA data, or the IRMA data from the National Weather Service, basically the high resolution observed temperature data, and calculating the number of hours at or above 100 degrees. And you can really see that, these are 3 days, June 26th, 27th, and 28th, during the peak of the heat wave, how the heat wave essentially moved in and then really consolidated across interior portions of Washington and Oregon here, with the third day of the event having upwards of 12, maybe more hours of 100 degrees or better. These are just devastating temperatures for that duration of time. And they're probably especially impactful in areas that are populated, urban areas and areas that you just don't see a big recovery. Even if you drop a little bit below 100 degrees, it's still oppressively hot in these areas. Next slide, please. So WPC has done a number of talking points and messaging. Basically, the center specializes in kind of telling the nation's weather story. And when there's something of this magnitude going on, we're always looking to coordinate with the National Weather Service offices in the area, and also the regional operations centers, in terms of messaging these events, both from an impactful point of view, but also historical context. A couple of these charts here were done in 2020, just showing heat index values at or above 100 degrees, population within those values. We developed a whole set of talking points for the Pacific Northwest event, developed an internal frequently asked questions, and then of course tapped some of that NWS safety messaging that Danielle was just talking about in terms of our social media feeds and other messaging avenues. Next slide, please. You can use the WPC website. We do the heat index forecast for days 3 to 7. I think this is in need of some modernization, especially with some of these other methods we've talked about. Heat risk is something we're definitely interested in starting to incorporate nationwide in terms of mapping, and that's something on the table for discussion as we go down the road. But as of now, you can always go to the forecast tools page. There are a number of tools there that can be used to put these events into context, 24-hour changes, the GFS probabilities if you're looking at highly anomalous events, the situational awareness tables. I particularly like the NDFD max-min departures from normal maps that are done out through 7 days. And recently this year we added the weather in context viewer that allows you to view the output from the various forecasts from NDFD to NBM with respect to records and also distribution within the ensembles. Next slide, please. So let's pivot to taking a look at the season again, June, July, and August, in terms of the number of heat advisory events and the standard departure. Again, these came from the excellent Iowa Mesonet plotter, and I worked with that last week to do this. So on the left are basically just the heat advisory counts. These are from VTEC event count, and then a standard departure or standardized departure from average. And again, no surprise here, you're seeing the same pattern that we saw with respect to the anomalous temperatures during the summer months. So well above normal advisories across the interior West and also parts of the Northeast. So very few parts of the country saw lower than normal events as far as heat advisories. Next slide, we'll look at the heat warning events, and again, fewer than heat advisories, but certainly the West is lit right up. I know we did have some interesting events with tropical cyclones like we did the year before. I think parts of Louisiana actually lowered their heat warning criteria just a bit, given the vulnerability of the population there after losing power in the wake of tropical cyclones, but dealing with oppressive heat and humidity in those areas. So even though we saw in the temperature anomaly slightly below normal across this area. What's interesting is that in the heat warning products, we see slightly above normal issuances for June, July, and August. So kind of another discussion item, somewhat of a disconnect between the impact and the actual meteorology, and actually these products trying to get an impact and advise the general population about the danger of heat, even though we may not be calling it all that dangerous when we looked at purely meteorological data. And then finally, the last slide is just a review of the number of days, heat advisory and excessive heat warning days. So widespread in the West, also in parts of the Southern Plains, and the West also dominates with respect to the heat warning days this past season. Not quite as many in the Northeast, although they had their scattering of events throughout the summer months. And I think that's all I have, just providing an overview here, and I will pass it over to Jacob, I believe, to talk about the local events in Seattle and communicating the unprecedented.
Yes, thank you, Greg, so much. Jacob DeFlitch, and as Greg mentioned, he's a meteorologist from our Seattle weather forecast office, and he's going to be doing a case study with us. So go ahead, Jacob.
Thanks, Danielle and Greg. Yeah, thanks, Greg, for that intro and leeway there. I think that's a great theme going into the talk that I'm going to talk about, which is talking about the Pacific Northwest heat event that we had late in June. And as Greg kind of mentioned, one of the main themes of this is going to be how do you message an event that you really have never experienced before. And that's kind of the the main theme that you kind of see through this entire event that we had through late June, and really communicating the unprecedented with regards to the heat event that we did see. So I want to kind of organize it in kind of several different stages here. Initially talk about the pre-event, kind of go over some of the ensemble guidance that we are using with regards to the forecast, talk about the briefings and webinars that kind of headline this stage of the pre-events, and also kind of dealing with that challenge of communicating the unprecedented overall. During the event, continuing the briefings and webinars, but also talking about social media and things I experienced while working the event, but also while living here in Seattle during the events, and kind of my experience going through it. Post-event, kind of talking about the draft kind of after action review process, the hot wash process, and working with partners, and then obviously the continued event, which is pretty much nonstop, always continuing ways we can improve in the future with regards to heat events, things that we noticed, and kind of trends that we had with our feedback with partners. So you can go to the next slide there. So starting off with forecasting the potential, and I really don't want to get into the nitty gritty of forecasting this heat wave event, but I do want to highlight some of the ensembles that were used about 7 to even 10 days prior to the event. So on the left side of the screen, you see the WPC cluster analysis, which we use, and this is about 7 days ahead of the event, 7 to 8 days actually from the hottest time period. But you really see that significant ridging starting to build across the Northwest. There was some uncertainty, of course, as there usually is with regards to maybe the ridge access or the timing of the ridge. But for the most part, guidance was generally consistent that a pretty hefty ridge was going to build across the Northwest and into southwestern BC in Canada. And then on the right side, you start to see the max temperatures really become noticeable on the EFI table from the ECMWF, highlighting kind of the anomalous maximum temperatures to climatology. And a lot of this discussion was obviously in office at first through in office talks, email briefings to ourselves, etc. But then of course we have to take this information, then provide this messaging to the partners. And so if you go to the next slide, you can start to see how we kind of did that and how we kind of crafted our message. So one thing we've tried to really start doing, and really we have done over the last year or so, be that with last year's snow events that we had, or this year's heat event, was introducing probabilistic information. In this case, we introduced it with heat and hot temperatures and maximum temperatures. We've done this before with snowfall to great success from partner feedback as well. But the focus shifts from what we see on ensembles and forecasts to, okay, how do we communicate this, not only with our partners, but also to our public on social media platforms and what have you. So one way we do that, as you can see on the graphic there, is kind of these horizontal bar graphs. And you can see both Saturday and Sunday there. So the respective high temperature on Saturday was 102. You can kind of see the probabilities from the National Blend of Models, which is what this forecast probability table is from. So you see the chances over 102 about 35%. So on the higher side, but still showing in the realm of possibility. Sunday, kind of the similar theme here on the higher side of, high temperature being 104, but still in the realm of possibility from the NBM, showing 50% chance of 100 degrees or more. So this just shows the opportunity that we can provide with regards to kind of the uncertainty of the forecast, but we were certain no matter what that it was going to be hot. I mean, 90-degree temperatures here for one day in a row, if not 2 days in a row, is significant when you have the lack of AC that we do here across Seattle area and Western Washington. But of course, we had it for, I think, 3 or 4 days in a row too. So it's one way to do it. And we also do this with low temperatures as well, because low temperatures are obviously a big key to how much it cools off at night, which it really, unfortunately, didn't do much during the event in late June. Next slide, please. So another way we communicated the risk, we incorporated these kind of temperature ranges from the probabilistic graphics generator provided by the WAVE team here at NWS. So you see a range on the left side there. So I'm going to say, for example, at Seattle Metro, remember the high for Sunday was 104. So this was forecast was made 3 days before Sunday. So you can kind of see it's obviously in the range of 97 to 109, with the best forecast being 102. So still providing that uncertainty, but also showing that we are certain that it's going to be hot and likely in the triple digits based on this forecast 3 days out for Sunday. On the right side, as Danielle already talked about the heat risk, you can kind of see the areas that were covered, showing, you know, pretty much during this 3-day period, everyone was vulnerable, but the hottest days, Sunday and Monday, being the hottest days for Western Washington, showing that high heat risk for a good portion of our area. So next slide, please. So we have that information, but we want to kind of do is put that into sensible weather terms. How does that impact the public? What can, you know, people do to prepare for such an event? What impacts can they possibly expect? So one of the main themes we try to hit on, not only with every webinar and briefing that we send to our partners, but also consistently on social media, was posting these call to action messages to show some type of repetition that the idea was, okay, this is what you should do to protect yourself during this upcoming heat event. So you see the call to actions there on the right. Some of those wordings were stronger than others, staying outdoors if possible from 10 to 4, but also the general, you know, wording of using life jacket flotation devices, because increases in the water-related accidents were a concern during this heat events. But you see on the left side there too, potential heat impacts. So not only do we have the calls to action, we also mentioned the heat impacts as well. So you see some of those there. One of them that isn't there was our impacts actually to our mountain snow. We're obviously just coming out of kind of the spring season for the most part. It's late June. Still have a pretty healthy snowpack across Western Washington, especially, and you know that becomes a concern. And then we spoke with our National Avalanche Center or Northwest Avalanche Center that we work with to discuss kind of issues and impacts there. So it's another impact, but things you have to think about when you're not dealing with something you're usually used to when it comes to such a significant event. Next slide, please. So pre-event continuing outreach work was done. On the right side there is our WCM Reed Wolcott. He did go to the city of Seattle for a press conference with our mayor, Jenny Durkin, for Seattle, and kind of spoke during that press conference and really highlighted the concern that we had with the upcoming forecast to the media that was there. And then obviously that message was broadcasted and taken by a number of different media agencies. The Seattle Times took that message and ran with it and made it a headline in an article for them as well. So just one of the outreach opportunities that we did, our MIC Logan Johnson worked with public health officials and human services to discuss the efforts surrounding the homeless population, which obviously when you have multiple days in a row of triple digits or 90 degrees is a concern here in Western Washington. So we met with them, or he met with them, to discuss those concerns. We did constant calls with the city of Seattle locally on a daily basis, both prior and during the event, to give them updates of what we expect. And virtual office hours were held during our time in the office to pretty much give an informal setting for emergency managers to come on a Google Meet platform and just ask questions outside of a webinar setting, just kind of a more personal, informal setting that we could, you know, meet with emergency managers. If there was any questions that they had for the event, we'd kind of answer those questions more tailored and specified for their area. Next slide, please. Some talking points, just want to briefly show kind of the talking points that Reed had when he presented to the city of Seattle and with Mayor Jenny Durkin. Want to highlight number 5 with the focus on the impacts and making the forecast unprecedented. 5 says, I will leave you with this. This is an unprecedented event. Those of us at the National Weather Service in Seattle have never seen forecast data like this. So one of those ways just to really emphasize the concern through wording, and this message was then taken to our social media platforms and any message we had in the future, really highlighting the concern that we had and urging people to take precautions and steps to make sure they are safe and protected during this heat event. Next slide. So we also, of course, did work on our social media platforms, provided more or less the same information we do in our briefings and webinars, although tailored a little bit to more of a social media type aspect to it, but providing temperature ranges as well as heat risk information, as well as timeline information, and just kind of leading the charge with regards to the heat event across Western Washington from our NWS Seattle account. Next slide. Okay, so during the event, I worked during the event. I worked all the way through Sunday, and then Monday I was off. So Saturday, Sunday, and Monday were pretty much the hottest days here in Seattle, although they were bookmarked by hot datas as well. So, you know, one of the main concerns is Seattle is one of the least air-conditioned metropolitan areas in the United States. Many of the homes here are kind of built to retain the heat, given our kind of mild climate located along the Pacific coastline, and the potential for colder winters compared to hotter summers. Obviously, that's becoming more of a concern as we have, you know, increasing climate concerns. But, you know, that's kind of how it's currently staged here in Western Washington. Another issue was it was a weekend, so all the hotels were essentially booked, be that from people visiting and or people had already booked hotels. I myself looked Sunday night when I was off because my in-place, my temperature inside my apartment was in the mid 80s when I got off Sunday night. So, you know, I had to find different ways and unique ways to stay cool. One of the ways I did that was I actually put the tent up in my living room. I faced my portable air conditioner inside the tent, and I put a tarp over the tent, and I slept in there Sunday night and I believe Monday night as well. And the whole day on Monday, I stayed in there with my dog Echo, because you have to stay cool somehow. My floor faces south, and in June, late June, you have 18, 19 hours of daylight here in Western Washington. A lot of complications to think about when you're leading to an event like this across an area that doesn't see unprecedented or, you know, that hot temperatures on a usual occasion. So thinking of finding ways to stay cool, not only for ourselves, but that's definitely an action item in the future when we take it going forward with regards to heat events here. What are different ways people can stay cool if they need to, and such an event does happen? Next slide, please. So after the event, some after action review process was done. I'm sure many do this, kind of a hot wash event. We reach out to partners, we gather some feedback, what went right, what went wrong, what can we do differently in the future? Then we try to implement that into our own system, into our own forecasting process. How can we make changes down the line in order to kind of tailor our forecast better to partners? What information can we provide better? Messaging, continuity, collaboration with each other can be done, because such a significant event, a lot's going to come out of this. This suggests, hey, there's a lot of changes that we can make and things we should make in the future, things that we did notice to hopefully minimize any impacts down the line. Next slide. So I just want to briefly go over a quote or two from some of the partner feedbacks out of the services provided that we had. One of them says, the geographic specifics in this event were invaluable and enabled us to take appropriate steps. We understood how Seattle would be impacted, as well as various parts of King County, which is served by the Human Services Department, Aging and Disability Services Division, including the possible temperature range along with the expected forecast was very helpful. So it's a continuing theme that we do see with the probabilistic information, even with maximum temperatures, providing them with that information. Again, not only showing that it was going to be hot with a 95% chance of seeing 90 degrees or more, but also it could be extremely hot, something we have never seen before, and providing them with that data so they can use that to make those decisions that they need to. Something else that was noted was calls to action statements that I showed on the previous slide. It's important to keep those short and simple, kind of at an elementary school level, so they're pretty much easily translated for the partners, and it's kind of quick and an easy way to do that. So making sure those weren't too long and the icons are pretty user-friendly is something we'll keep something in mind in the future, which we might not have thought of prior to the event. Next slide. Some unusual impacts, and I don't want to go over all these, but there was a number, like I'd already talked about, the mountain snow concerns. The power grids were a concern. Obviously, it's a concern whenever, you know, indoor temperatures are in the 80s and 90s. Portions of the city that don't see outages and usually created additional vulnerable populations, and not to mention some of the trees starting losing their leaves, which left less shading there too. So a lot of, again, different ways to think about things that you might not have thought of before the event are actually impacts during the event. It's something to keep in mind of down the line. Obviously, fire department concerns were an issue, as well as the operation rooms for hospitals shutting down with AC units going out. Next slide. So how can we take this moving forward? That's pretty much the overarching theme and the main question you have to gain from. And obviously, we're still in the process of getting feedback, parsing through that feedback, see what we need to do to improve down the line, because, you know, heat events are they're not going to stop. They're going to continue, as we go down future years. So what can we do with the increasing heat events? Mitigation efforts are necessary. And it's something we'll be working on with continued work and communicating, particularly with the vulnerable, underserved communities, like the homeless population, elderly, our tribal communities here locally, as well as limited English proficiency communities. Continued work with emergency managers for identifying areas of improvement. Like I said, with these heat waves, that's pretty much a continuous process, possibly kind of collaborating with EMs, doing local tabletop exercises, working with their emergency action plan, their EAPs, so we're all on the same page. An event does happen like this again, and identifying other potential tools available to use during such events, like the heat risk that we use, but also the wet bulb glow temperature as well, that we did not use as much, but something to introduce into future events. And also continuing further research, specifically on urban heat islands, which research has been done before with NOAA in King County, but also work outside of that, identifying those vulnerable areas and populations for such heat events that we'll see likely down the line. So that's all I have. I will pass it over to Danielle to introduce the next speaker.
Thank you so much, Jacob. Appreciate it. So I'm passing it on to Chelsea Peters now, who is going to give us a case study from a more traditionally hot area, Las Vegas. So she is a meteorologist at the Las Vegas forecast office. So welcome, Chelsea. Go ahead.
Thanks, Danielle. So this whole talk, I'm the last speaker, but kind of ending it where traditionally, like she said, Las Vegas and the Southwest see heat events every year all the time. And so out here, we communicate it more frequently, but that also comes with its own set of challenges unique to the desert Southwest. So, communicating heat impacts an already warm climate, like I said, has its fair share of challenges every year. And to mitigate those, we do our best, both pre-heat season and during heat season events annually. So things that we participate in before our heat season starts, which actually can be as early as mid to late May. We kick off things like our heat awareness campaigns, also Monsoon Awareness Week out here in the Southwest is very big, and we also cover heat as well. We engage in our stakeholders, so our deep core partners, in further developing those relationships and bringing in other folks like infrastructure, so local infrastructure people and health partners and everything, making sure that we continue to have those conversations before our heat season so that we are all on the same page and all communicating effectively. Additionally, we recently developed these one-on-one partner meetings. So we're having a more in-depth conversation with some of our core partners on a one-on-one basis so that we further educate and communicate with them, both our operations and theirs, so we can develop that trusting partnership and all be on the same page with the anticipation of heat. Additionally, something that we did this year, we usually do some type of media day, but what was challenging just specifically because of COVID was the fact that we haven't had a lot of conversations with our media partners in a while. So this year we tried to focus on further education on heat risk, that tool in which we primarily use out here because of its effectiveness in being able to communicate the climatology and all those things that Danielle talked about that goes into the tool. And so further educating our media partners and having kind of one-on-ones with them and each TV station so that, because our relationship with them is crucial, right? They are further amplifiers of our message, and it helps to develop and have that trust with them. So we went ahead and had virtual meetings with all of our media partners, and we're able to develop that relationship and educate them on things that we're doing and things that they're doing so that we can all be on the same page during this heat season. And then during the events, we, like most other offices, communicate things to the public via social media graphics. And then also with our partners, we usually with heat events luckily have pretty good lead time and are able to, in general, see that a big heat event is coming. So we're very proactive in putting out email briefings to our partners. And if it looks like that heat event, because like I said, it's the desert Southwest, we usually are always, we're gonna have some flavor of heat. So it's kind of distinguishing how hot is this heat event going to be in comparison? Does it trigger the level of where we need to further amplify the message? What trigger is that? And for here locally, we kind of spin those up with webinars to kind of trigger our partners to be like, hey, this is actually, it's not your normal heat event. It's in a normal, very uncommon heat event. So that's kind of what we do here. Next slide, please. So similarly to what Jacob was saying and how this year we were able to utilize probabilistic information, and because of the most recent heat event that we had, well, we've had several, but there was one in particular in early July that was very unprecedented, 8 to 10 days of anomalous temperature, both highs and low temperatures were going to be anomalously warm. Looking at the climate stats, it was like there was only 2 or 3 times that this type of event has ever happened. And so we were trying to think, okay, how do we further amplify our messaging? How do we get across the rarity of this event? And so we turned to probabilistic information to just kind of further amplify, like, this is rare. We potentially have the potential of breaking our all-time temperatures. We're seeing that in probabilistic information and trying to be able to communicate that to our partners and the public to take action and plan and mitigate accordingly for the potential heat event. So next slide, please. Thanks. So with the fact that we have over numerous years have further developed these partnerships, have been very beneficial for communicating heat events and being on more of a collaborative messaging effort with a lot of our deep core partners. And this is just a few examples of the best relationships we've had and communication efforts we've developed with communicating heat. So particularly effective relationships with Southern Nevada Heat Coalition Group was developed to just kind of being, heat is a problem here, so how do we continue to strive and communicate that and mitigate as much as we can in terms of morbidity in heat in the desert Southwest. Some screenshots that I took of further, there's many, but a lot of our partners rely on our communication efforts, but they also prepackage and put it out as well. And it kind of goes back to developing trust with not only our partners, but also the public, so that we're all on the same page, we're all communicating the same way, that heat's going to be an issue, this is why, and this is what you need to do. And our relationships with our partners have been super helpful and have shown well in actually making a difference. And next page, or next slide, please. So another way, and this summer that we were able to, this is a similar graphic that I showed before, but probabilistic information with dealing with Death Valley, because we have the unique challenge of having Death Valley in our forecast region. And most of you probably are already aware that Death Valley holds the world record for the hottest temperature ever recorded. So during this event, we're trying to communicate, okay, what's another way to further amplify that this is going to be very rare, and making sure that we're on the same page with our partners. We actually, ahead of this event, had a meeting with Death Valley National Park to make sure we were all on the same page with our messaging, and they thought it was very beneficial. And actually what resulted of that is they wanted us to create a graphic with both of our branding on it so they could also push out the same messaging, which we rarely see this much shares, but Death Valley has a very large social media presence, and because they were able to further push this out, they got a record number of shares and was able to further communicate that the Death Valley is going to see anomalous heat, and it just so happened to be that we were forecasting record temperatures or near record for the same day that the 134 record was recorded, so July 10th. Next slide, please. So our collaborative messages have got us to this point, but another challenge, like I said, was Death Valley, where heat is the main attraction, right? Like, people go to Death Valley to feel and experience the oppressive heat. It's just a part of the complication factors that come into having Death Valley in your forecast area. And so because of that, it's actually, the summer is their second busiest time of the year for the park, which is the largest national park in the lower 48, which also has its unique sets of challenges because it's a very large park, but in a very remote area. And so the park itself has very sparse cell phone reception, and which comes at a cost when you have people that aren't used to experiencing heat of that magnitude in the summer, but then decide that they're going to go hiking and lose cell phone service or something unfortunate happens, and it's just a cascading effect at that point. So making sure that we have that deep core partnership with them has been critical. Recently, just this past year and last year, Death Valley recorded a temperature of 130 degrees, which has created its whole set of challenges because of the fact that temperatures of that magnitude have not been recorded in a very long time. And so further communicating those impacts and how uncommon and unprecedented they are for that area, and a slew of other impacts associated that have come with its own set of unique challenges. Next slide, please. So the challenges we face here in Las Vegas, as I've alluded to, is basically distinguishing and communicating extreme heat from normal heat, and the slew of challenges that occurs with that, because people don't have urgency when we're, oh, it's Las Vegas, it's going to be hot. Yes, but distinguishing that and communicating it to a way that people actually take action and mitigate is a challenge. Another one is communicating excessive heat to vulnerable and marginalized communities. Obviously, like the homeless and transit population. What's unique to Las Vegas also is that we obviously have very high tourism. So on average, 42 million people visit Las Vegas every year, which is a lot. And a lot of that actually occurs in the summer. And people don't realize how hot the temperatures are. Yes, it's dry heat because we have little in the way of humidity unless there's monsoon season brings moisture around. But overall, people just aren't prepared for this type of heat out here, and it's just very challenging to communicate. Like, when people are coming out of town, they don't realize and then go for hikes, and it's a problem. So trying to develop those relationships with our partners has been critical, particularly so that we can mitigate any of those risks and let people know that are tourists of those issues. The homeless too, because of it gets really hot out here. Our minimum temperatures don't drop very low. We had like 9 days where our minimum temperatures this summer during this heat event that we had only got to around 85, 90 degrees, which is, there's no overnight relief from that. And so a lot of the homeless tend to seek shelters, and in the underground cement washes, which comes at a secondary impact because if we do get monsoon storms, we have during the day, it gets really hot. A lot of the homeless population seeks shelters in these drainage basins, but then when we have flash flooding come in, the water goes into these drainage basins where it's supposed to. And so it potentially leads to impacts where the homeless may need to get multiple swiftwater rescues. And yeah, so lots of challenges there. Additional things are the infrastructure impacts, like I mentioned, that when it's very, very hot, we get very stressed power grid, which in turn equals the potential for failure. Also, when you look at the personalized AC failures happen quite a bit, and that results in the influx of repair workers, which we just don't have meet the demand a lot of the time because the demand is higher than the supply type of thing. So a lot of cascading effects happen in the desert Southwest where it is normally hot. In addition to that, actually this summer when we had those very hot overnight temperatures for 7 to 8 days, we actually had an event where there were shelters that were opened, but they didn't actually, they were outside. And so when the outdoor shelters for cooling centers were open and they were outside, the overnight temperatures just weren't enough, and the fans with mist weren't cooling off all of the people enough. So they had to quickly spin up indoor shelters, which was an issue. And they're going to, and I've actually worked this week with a partner and emergency manager to communicate, figuring out to communicate to the city council talking points on how unprecedented this is so that they don't have that issue next year, and they have funding to get generators so that communities are actually getting effective cooling at these cooling stations. So kind of just to wrap up, I know we're running close on time. Because of the heat out here in the desert Southwest, we continue to do these efforts with both pre and during, and we're going to continue to further expand in development of our partnerships, particularly with the local school districts and our county coroner. But the key point is to, in the desert Southwest, to stay relevant and consistent in our messaging for heat dangers and heat impacts so that we can reach more people with the ultimate goal of preventing lives lost due to heat. That's all I have.
Thank you, Chelsea. I believe we have a couple minutes. And if we could get everyone back on camera real quick. I will stop screen sharing. Trevor, do we have any questions that have come in from GoTo or Twitter or elsewhere?
Not actually from any of those, but I had a question for everybody. It's probably more focused on Jacob and Chelsea, but there's a lot of webinars we've been dealing with and talking about events that are not necessarily heat related, but talk about having major events that have been going on with a pandemic ongoing. And so I was curious if you had, in either of these experiences, that you had any impacts that were exacerbated as a result of, you know, the COVID-19 pandemic, going on.
Yeah, I'll take that to start off. Yeah, one of the main ones to think of is going to be the shelters, likely being open. Some were open, and I believe some were still closed. You know, there's a lot to think about when you go into that. Like Chelsea said, there's a lot of cascading impacts there, and you know, that's just another issue on top of everything that you have to think about going into this. And I think shelters was one of the main concerns. I think a number did close around, you know, 8 or 10 p.m. Reminder though, people are going home to their homes and the indoor temperatures aren't peaking until 10 p.m., especially during June, whenever the sun shines out for 18 hours a day. So, you know, I think that's probably the main impact, but I know there was probably others. I know we have some in our office personally. You have to think about operations and forecasting. So there's different ways to think about that when you're going to such an event, but that was a good point and definitely a play or two.
Yeah, I guess I would say what the challenges we faced here locally is just because we've already developed these relationships with our partners. I mean, it's kind of like keying in and making sure that we're still relevant and that heat is still an impact. COVID is this big looming thing, but heat is an impact secondary as well, and how that is going to play a role. And so because of the COVID aspect, making sure that we're still connected with our partners was a challenge, but luckily with this virtual world, it opened up all these different avenues of ways that we've been able to interact with them on a more one-on-one basis.
Well, thank you for everyone participating. I hate to wrap it up after just one question, but we're at an hour now. So I'm going to thank all of you, including you, Danielle, for hosting today and walking us through the HEAT program and the local impacts from the 2021 summer. And of course, Greg, for the national review of just how anomalous this summer was. I hate to say, but we'll probably be looking at having discussions like this in the future for the next several years. But there's a lot to learn from it, and especially from your two events, there's a lot that we can start getting worked on tomorrow, and start preparing for the next one. So thank you all for being here and participating in the NWA's October webinar. And for everybody else, if you didn't get a chance to ask a question, you could always do so. All these folks have been tagged on Twitter if you would like to ask them questions there. And we will be back again for our next webinar, hopefully next month, but at the latest in December. And if you ever want to come back and see these, you can follow us on YouTube as well and subscribe, for all of our webinars are posted there after these talks are done. So thank you one more time for all of our panelists and presenters, and we look forward to seeing you all for our next episode.
Thanks, Trevor.
Thank you.